In the previous video, we looked at the dot structure for sulfur dioxide, and I drew out two resonance structures. So the resonance structure on the left and the resonance structure on the right. And some people disagreed with me and said that's not the dot structure for sulfur dioxide. The dot structure for sulfur dioxide has sulfur with a double bond to an oxygen on the left and two lone pairs of electrons on that oxygen, and the sulfur with a double bond to an oxygen on the right and two lone pairs of electrons on that oxygen. And then we have a lone pair of electrons on our sulfur. So the advantage to this dot structure is we don't have any formal charges. So the formal charge on sulfur is 0, and the formal charge on both oxygens is 0. And so this is a valid dot structure, right? There's nothing wrong with this dot structure. It's fine. If we look at sulfur, we count up the electrons around sulfur. Here's 2 and 4, 6, 8, and then 10. So we have more than 8 electrons around our sulfur. So sulfur has an expanded valence shell. So this is expanded. We have more than 8 electrons around it. And that's okay to do because of sulfur's position on the periodic table. Sulfur's in the 3rd period, so we have some d orbitals. So we can have more than 8 electrons around sulfur. So that's fine. So this should be a valid dot structure. If we go back up here and we look at one of our resonance structures, I'll take the one on the right, we do have formal charges, right? Which usually our goal is to minimize formal charges. If we look at this sulfur right here and we count our electrons, we have 2, 4, 6, and then 2 more for a total of 8. So we have an octet of electrons around sulfur. So for this resonance structure, we have an octet of electrons, but we have formal charges. Down here we have an expanded valence shell, but we have 0 formal charges. So which version of sulfur dioxide is the correct one? So in my opinion, they're both fine, because for the first version, right, when we draw two resonance structures and we put in our brackets and everything, we are saying that the actual structure is a hybrid of our two resonance structures, right? So sulfur dioxide doesn't look like this, it doesn't look like this, it's a hybrid of our resonance structures. So if we just think about bonds, right, and I draw on our bonds here, the bond of sulfur to oxygen. Well, if we look on the left, let me use a different color here, we have a double bond between sulfur and oxygen. On the right, we have only a single bond here. So a hybrid of these two resonance structures would say that this bond is in between a single bond and a double bond. So we could put a dotted line here like that. And on the right, our bond between sulfur and oxygen, let's look on the right. Let me use a different color here. I'll use green. Over here we have a single bond, and over here we have a double bond. So if we put in a dotted line, right, that bond is in between a single bond and a double bond, so like that. And experimentally, both sulfur-oxygen bonds have the same length, which is what our hybrid shows us, right? Our hybrid shows us the same length between our sulfur-oxygen bonds. So in my opinion, it's fine to represent sulfur dioxide with these two resonance structures. And I looked in several general chemistry textbooks, and actually most of them give you this as the answer. So some of them give you this as the answer. And in my opinion, they're both correct. Sometimes you can only figure out the best way to do something like this by using quantum calculations, right? And that's just way too complicated for something that we're talking about. Both of them will tell you the shape of sulfur dioxide, right? Both of them give you bent geometry around your sulfur. And so we might change this depending on what teacher you have, right? So some teachers are extremely strict about minimizing all formal charges, and so they might expect you to draw this version, right? Whereas other teachers are fine with drawing resonance structures and thinking about a resonance hybrid. So do whatever your teacher wants you to do, but in my opinion, both of these are correct, and it's not really worth debating about too much.